Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on electronic configuration and orbital diagrams. In our last lesson, we studied the shapes of orbitals. Specifically, we looked at the shapes of S, P, and D orbitals. We learned that while we cannot know the precise shape of these orbitals, we can determine their general shapes. This allows us to draw a boundary within which the electrons are probably located. There are several questions that arise when we begin to explore the electron configuration of atoms. In order to answer these questions, we must be aware of some basic principles that govern the distribution of electrons among atomic orbitals. The following three principles explain the electron configuration for any atom: the Aufbau principle, Hund's rule, and the Pauli exclusion principle. In today's lesson, we are going to learn about the Aufbau principle, which is also called building up principles. We will also write the electronic configurations of some elements. We will discuss Hund's rule and Pauli's exclusion principle in our next lesson. Students, let us begin with some quick review. As you know, in quantum theory, the electrons that surround the nucleus of an atom are assigned to orbitals. We learned in our last lesson that each of these orbitals has a characteristic energy and three-dimensional shape. Also, a maximum of 2 electrons can be assigned to each orbital. So far, we have discussed 3 orbitals, but there are actually 4. Each S subshell contains only 1 orbital. Each P subshell contains 3 orbitals. Each D subshell contains 5 orbitals, and each F subshells contains 7 orbitals. The word Aufbau is German for building up, which makes it a very suiting name for the principle we are discussing today. The Aufbau principle states that, in general, electrons occupy the lowest energy orbital available before entering the higher energy orbitals. In other words, electrons orbit in the space closest to the nucleus of an atom before expanding outwards. Electrons are most stable when they are at this ground level. As the number of electrons increase, they begin to fill the next highest energy levels, building outwards from the ground level. This image shows the order of filling orbitals. 1s is the ground level, and the electrons build out from there. Teacher, please divide the students into groups of 3 or 4. Students, in your groups, please discuss why there are never more than 2 electrons in an atomic orbital. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure that you had some very interesting discussions with your group. I wonder if you were able to think of the correct answer. There are never more than 2 electrons in an atomic orbital because an atomic orbital is a mathematical function that describes the wave-like behavior of either one or a pair of electrons. Atomic orbitals are the possible quantum states of an individual electron in the collection of electrons around a single atom. Let us move on and discuss how the Aufbau principle relates to the ground state electronic configuration of the elements. The electronic configuration of an atom describes the distribution of the electrons among atomic orbitals in the atom. There are 2 methods that are used to describe the electron configuration of an atom. The first method, which is known as subshell or sublevel notation, uses numbers to designate the principal energy levels. These numbers are also referred to as the principal quantum numbers. Letters are used in this method to identify the subshells or sublevels. A superscript number following a letter indicates the number of electrons in the designated shell. Students, draw simple diagrams showing the electronic configurations of hydrogen, helium, and lithium. Explain how the Aufbau principle applies.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. How did you do with this activity? Please compare your drawings to those that are on the screen. These three elements provide a great example of the Aufbau principle. As you can see, the hydrogen atom only has one electron, which is on the 1s orbital. Helium has a pair of electrons. They fill the 1s orbital. Lithium has 3 electrons, so it builds out from the first two elements, filling the 1s orbital and starting onto the 2s orbital. The other way to show electronic configuration is by using an orbital diagram. This consists of a box for each orbital available in a given energy level, grouped by sublevel, with an arrow to indicate the electron's presence and the direction it spins. Here, you can see how hydrogen, helium, and lithium would be expressed using orbital diagrams. In today's lesson, we learned about the Aufbau principle. We learned that according to this principle, electrons generally occupy the lowest energy orbital available before entering the higher energy orbitals. We also learned about two methods of presenting the electronic configuration of atoms: subshell notation and orbital diagrams. We learned how to use both of these methods, and we learned how they are related to the Aufbau principle. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.